All right, so today we're getting ready for the mid-module that we'll be taking soon. And we're starting off with line plots. We only covered one lesson on line plots. It's more of a review lesson than anything else. So we're going to look at answering a couple of these questions. So the line plot below shows the distance students live from the school. What is the difference in miles between the students who live closest and furthest away? So we're looking at what is the difference in in miles between the students who live closest and furthest away. The first step is we have to figure out who lives closest and who lives furthest away. And reading the line plot, it's not exactly the person who has the most X's is the one who lives furthest away. It's the one who on the line plot or number line is the shortest distance and the longest distance, or who lives closest and who lives furthest. So on number one, we can tell that the person who lives the closest is 5. The person who lives the furthest away is going to be found on this line right here. So we are at 6. And 1, 2, we have 1 gap, 2 gaps, 3 gaps, 4 gaps. So it's in fourths, so 6 3/4. So we need to find the difference. Now we need to make sure we put them in the correct order when writing our subtraction sentence. So 6 3/4 minus 5, pretty simple.
Email, or I just went up there and got them.
You just went up there and got them?
Yeah, they're in the front.
Okay,
They're all up there congregating, so.
I'll just go up there and get them tomorrow.
Okay.
All right, thank you. Well, I thought I paused that, but I didn't. So we have 24 as the whole. So we just needed 3 of these. So we have our 3 levels. So what's 6 plus 6 plus 6? We have 18. So he gave away 18 Pokemon cards. Now I was telling the students that when you see this word "of" here, he gives 3/4 of his cards away. So we can take away his cards and say he gives 3/4 of 24 cards away, and that makes this a multiplication problem. Which I know this doesn't look like multiplication, and really it just becomes division in the long run, because that's basically what happens when you multiply a whole number by a fraction. But we need to see that we can just switch these out and easily make a tape diagram. And really, we're making a tape diagram for almost every single question. I know I went through the test and I made a tape diagram for every single question to see if I can tell the kids, hey, you can just make a tape diagram for every single one. And you can, except for the plot line one. You have to wear the plot line one out by yourself. Let's see, what else do we have this year? We have one where we simply just ask the students, can you divide a whole number, and what is your fraction answer for that? So I believe the students today had a practice question where it was like, Tom bought an 8-foot board. Tom wants to cut the board into 9 equal sizes or pieces. How many feet are each board? Now, we're going to ask for this in a fraction greater than 1, or as we know, an improper fraction, and then we're going to ask for it in a mixed number. And so we need to figure out, we know he's going to create equal sizes. So we know equal sizes is a way to say, we're going to divide. We need to figure out what's being divided and what it is being divided into, how many groups it's being divided into. Well, we know that 8 is being divided, and we know we're trying to make 9 equal sizes. So we can easily say 8 divided by 9. Well, what is 8, 9? Let me change these numbers so that we can actually answer it the way I I want to. We're going to change it to 9-foot board with 8 equal sizes. So it's going to be 9 divided by 8. And so 9 divided by 8 is the same thing as 9/8, because we know that the dividend goes in the numerator and the divisor goes in the denominator. Well, this is a fraction greater than 1. And then we need a mixed number. And we know a mixed number is just how many groups of our denominator are in our numerator. So we have one group. What's left over? 1/8. So this is our mixed number. All right. So again, this could have been solved with a tape diagram. We could have easily done what is, hold on one second. And then we are going to, we need to convert. So we're going to say, for instance, 2/3 of a foot equals how many inches? Well, we can solve this by saying 2/3 times 1 foot, which is the same thing as 2/3 times 12 inches, because we know 12 inches equal a foot. And then all we have to do is figure out, well, what is 2/3 of 12? Again, we can solve that with a tape diagram. 12 is our whole. We need to figure out what is 2 of the thirds. So we can say 3 units, because we have 1, 2, 3 units, equals 12, which is the whole. So if all 3 of these units are added up, they equal 12, because we do have equal size pieces. So then 1 unit equals 12 divided by 3, which is how many units we have. So 1 unit equals 4, because 12 divided by 3 is 4. We can check that. 4 times 3 is 12. So 4, 4, 4. But what is just 2? It is 8. So 2/3 of a foot equals 8 inches. And you can interchange this with a couple of things. Like we could say, let's try, I don't want to do one that's exactly like the quiz test tomorrow. Be a little unfair. I do want to see what they know. Let's do another foot one. Let's see. Let's do 5/6 of a foot equals blank inches. Again, we can say 5/6 times 1 foot. That's just breaking it apart from its unit. Then we can even say 5/6 times 12 inches again. And then another tape diagram. 1, 2, 3, 4, 5. 6 parts. 1, 2, 3, 4, 5, 6. 6 parts. We need 5 of them, though. So 1, 2, 3, 4, 5. And again, you can do the dots. You can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that one says 10. We can also say that 6 units equal 12, because 6 of these do equal 12. 1 unit. And then 1 unit. Oh, I spelled that wrong. Unit equals 12 divided by 6. Because remember, we're finding 6 groups. How many groups of 6 are in 12? And then that equals 2. And then there's 5 groups. 2 5 times is 10. Again, we can use tape diagram on every single question. That's what I'm trying to show the kids. And let's go back to Tommy has 24 Pokemon cards. He gives 3/4 away. What if we were to change this question to just erase all of this? If we were to change this question, he gives 3/4 of his cards away. how many cards did Tommy keep? Now, there's a difference between this question and the last question. The last question said, how many cards did he give away? This question is saying, how many cards did Tommy keep? Well, let's look at the tape diagram. Tommy gave away 3/4. So he gave away these 3. So he only kept this 1 unit right here. So what is this 1 unit? Now we can easily answer the question by going back to the old one. You can say, okay, well, you can do the dots again, which the dots didn't work. We can say, well, what is, 4 units equals 24. 1 unit equals 24 divided by 4, which then equals 6. Or you can do the multiplication on this one, because we do have a unit fraction up top, which is just 1, because we know that this is 1/4 right here. 1/4 times 24. We know 1/4 times 24 is really just 24 over 4, because 24 is in the numerator, because really it's 24 over 1. And then we can just simplify that to 6. So we know 1 unit is 6. But it's very important that we pay attention to what is the question asking of us. So I'm expecting to see some great grades. Students are really understanding this. I hope you have a good night.